Okay, here's another example of how to classify a soil using the Unified Soil Classification System, USCS. We're given the grain size distribution of the soil, right here, and we're also given that the liquid limit and the plastic limit are 60 and 20, respectively. That's, of course, of the finer portion of the soil, right? So what we can do immediately is figure out the plasticity index, which is simply the liquid limit minus the plastic limit again, right? 40. Okay, now we proceed with always, as the first step, always is the determination of the fines content. To get the fines content, we look for the threshold diameter, right? 0.075 millimeters. Particles smaller than that are fine, larger than that are coarse. This particular grain size distribution is such that it's common in the sense that it ends at 0.075. Notice that this is 0.7 or 0.07 and this is 0.08. The last point indicates that the last sieve used was the number 200. And below the number 200 sieve, which has this opening size, was the pan, which collected all the fines. Okay, so what is the fines content here? Well, we can just read the value, right? Okay, so that looks like something like 6%. 6%. Okay, so the fines content is 6%. That means that the coarse content is 94%. So is the soil coarse or fine? Obviously, it's coarse because there is more coarse content than fines content. Or the other way to say it is that there's more than 50% coarse, so therefore the soil is coarse. Okay, great. If the soil is coarse, we have to use the flow chart. And here it is. Okay, so this is a little bit big, so I have to zoom out a little bit, but okay, so you guys have this chart. It says begin, right? Is it a gravel or a sand? Meaning, is there more gravel than sand or more sand than gravel? Okay, let's go back to our plot. Where is the threshold between sand and gravel? 4.75, right? So 1, 2, 3, 4, 5. This is 4 and this is 5. 4.75 is very close to the 5. And if you go up, you find that it doesn't touch the grain size distribution curve, right? So there is no gravel. There's no gravel in the soil. In fact, the largest particle in the soil is denoted by this point. 100% of the particles are smaller or equal than that particle, right? And that's 2 millimeters. So the largest particle in the soil is a sand. Therefore, this entire 94% here is sand. There's no gravel. Okay, so that means that we go back to our chart here, and we are on the bottom side, bottom portion, okay, where we begin with sand. Now, the first question is listed, let's say, in this zone, right? It says less than 5% passing the number 200, between 5 and 12 passing the number 200%, or more than 12% passing the number 200. Well, passing the number 200 means fines, right? So do we have less than 5% fines between 5 and 12 or more than 12? Well, we already calculated the fines content to be 6%. So we are right here between 5 and 12. So we proceed. Here the next question is, what is the CU? Is it larger or equal to 6 or is it less than 6? Okay, so we have to compute that. What is CU? Cu is the coefficient of uniformity. It is D60 over D10. Okay, so we have to calculate D60, or determine, read it off basically from the chart, and also D10. Let's look at more closely. Let's get D60 first. Okay, so D60 is associated with 60%, obviously. So here's the 60 line. Here's where it touches our grain size distribution curve. We proceed down, and it's the value of a tick mark. So we're lucky, 0.2, 0.3. 0.3, right? D60 is 0.3. Now let's get D10. All right, here's the 10%. We hit the grain size distribution curve, we drop down, and it so happens that the value is located between 0.1 and 0.2. In fact, halfway between 0.1 and 0.2. We already know that to determine a value on a log scale that is between two tick marks, all we do, and I should say halfway between two tick marks, all we do is the geometric mean, which is square root of the value to the left, 0.1, times the value to the right, 0.2. So 0.1 times 0.2, and then square root of that, right? The square root of 0.02, obviously, 0.1414. That is this value right here, which is D10. Oops, look, D10. So 0.1414, which gives us a Cu of, oops, 0.3, 0.1414, 2.12. Okay, so that's our Cu. Coefficient of uniformity. So let's see what that does. Again, we are right here, right? Is our Cu more than or equal to 6? No, it's 2.12, so it's less than 6. So now we move along these two lines. Well, which one? Here, the step is associated with figuring out what type of fines portion we have. Okay? So we go back to our data, and we realize that our fines portion is characterized by a liquid limit of 60 and a plasticity index of 40. So to characterize the fines portion of our coarse soil, we come to the plasticity chart. Okay? The liquid limit of our fines portion was 60, and the plasticity index was 40, or is 40. Here's our point. So our soil, that is the finer portion of our soil, is a CH. So this is a sand, right? Because it's predominantly sand, but its fine portion is high plasticity clay, CH. So we go back to the flow chart, right? We started here, sand, 6% fines, down to Cu less than 6 because we got 2.12. And now, what do we have? Right here, CH. So we follow this line, because here's our CH. And then we proceed, and our answer is SPSC. That's the group symbol. That's what we're looking for, okay? You can proceed this way and determine how much gravel, etc., which in our case is 0, and have a more distinct classification, but generally, for practical purposes, we end after we find the group symbol. Okay, so our group symbol is, for our soil, is SPSC. This is a poorly graded sand that has high plasticity clay in it. So our answer answer is SPSC. Okay, just one last comment here. Notice that if we had had our CU larger than 6, we got 2.12 for our soil. But if for some reason the CU is larger than 6, right, then we have to calculate the C sub C, the coefficient of curvature, and figure out if we proceed this way or that way. And again, very simple, it's just an if statement, right? Okay, in our case, we didn't have to do that because our CU was less than 6. So we skipped the calculation of C sub C, it's not needed, as you see here.